Okay, next we're going to put together two ideas that we've already explored. The idea of cross-canceling, along with the idea of factors, basically. So, in this example, basically the n plus 4 here can cancel out. So, yeah, you could just draw one line through, but sometimes you like to scribble it out just because you won't get confused. So this n minus 3 can also be canceled here. Okay. So we'll be left with 7n squared over the product of these. And you can either FOIL that out or you could just write it in factored form. Either possibility might appear as an answer choice. So you should be comfortable with both ideas. Okay. Next one here, these r plus 4s can cancel, right? Because this is a factor. It's not involved in, collectively it's not involved in any addition or subtraction problem. The r plus 4 here is not being added or subtracted. Okay, so those both are factors and therefore they're able to be canceled. These 9s could also go. Now, can these r's go? The answer is no, because this r is involved in a subtraction, making it a term, not a factor. Well, whereas this one is a factor. Okay. So anyway, we end up with 9r over r minus 5. Okay. Next up, this p minus 4 can be canceled with either of the ones below. And that's about it. So the rest is just going to be the answer. Yeah, I'm just not going to write it, but you get the idea. Here we can cancel out these 7s along with the n's. And yes, you should think of those as separate. So it's not 7n, one unit. It's 7 and it's n. Okay? They're separate factors. Now, here I could factor out a 3. I'll be left with n minus 8. And then we can work on this one down here. We can factor out an n squared. And we'll be left with, well, we could also take out numbers. Let's see. We could take out, let's see, this is 6 times 4. And this one is 8 times 8. Right? Well, maybe I ought to use 8 then. So if this is 8 times 8, then this one is 8 times 3. So if I factor out an 8, I'll be left with a 3 in the first position, along with an n, because I took out 2 n's. Here, if I took out an 8, I'm left with an 8 inside, and I'm left with no n's, because I took out both of those n's. Okay. Great. So now, yes, this has now been factored. You can remove it. And so has this. Okay. So what we're left with so far is 3 times n minus 8. And on the bottom we've got 8n squared, 3n minus 8. Okay. So can anything be reduced from there? I don't think so. I think that's about as far as we can go. Let's see what else we have in store here. Well, for this one I could factor out a 7 using the idea of greatest common factor, and I'll be left with p plus 2. Then these p plus 2's can cancel, right? Then I could write what's left over. So it would just be this, and conventionally we write the number in front when we have a number and a binomial. Right, so here we may have to do a little bit of trinomial factoring. So p and p, the plus goes there. This minus indicates that it's different from the first symbol, so it's got to be a minus. And then the numbers, I believe, are going to be 9 and 3 that multiply to 27 and combine to 6. Okay, then the p plus 9 can cancel with this p plus 9, so we'll end up with p minus 3 over p minus 9. Right, so we kind of get the picture of how these are going. We can go to the next page. And yeah, so here are some more problems that involve the various methods of factoring. So here we could take this and break it to a plus 9. Well, my a's look a lot like 9's. Try to exemplify the difference. A minus 9. And then factor out an a here, and we're left with a plus 9, right? And then here we have to use trinomial factoring. So the minus and the plus 9 and 2, right? Then we can cancel out the a plus 9s. We can cancel out the a minus 9s, right? And we can also cancel out one of these a's, right? So again, I don't want you to think of this as 5a squared. I want you to think of 5 and a, and even a squared is really just a times a. Okay, so this is 5 times a, really. One of those a's can be canceled with this a down here, right? So you're left with just 5a on the numerator. The bottom has got a plus 2. Of course, these a's cannot cancel because this a happens to be part of an addition problem, making it a term, not a factor. Okay. So here I'm going to factor out a 3. I'll be left with 2p plus 9. Okay. And then here I'm going to factor out an 18. I'll be left with p. Well, also take out a p. Will be p plus 2, right? Here I would take out a 2 and have p plus 2. And here, okay. So I already made a mistake, which is I factored before I did anything else. Well, let me just finish and then I'll explain the mistake. So p plus 4 here. So when you're dividing these things, the first step that you're supposed to do is you're supposed to switch it to a multiplication problem, whereby the first group stays as it is. Okay, so I'm just going to write the factorized form, and then the second group is supposed to flip upside down. Okay, so I'm just going to take the factors and flip them instead. P plus 2 and 16 p plus 4. Okay. Yeah, so what's typically done is this is then written upside down with a times in the middle. But in the interest of saving time, we'll just do so with the factors. Okay. So now p plus 2 can cancel, right? And some of these numbers can be reduced. So the 2 and the 16, this 16 is really 8 times 2. So the 8 is what's going to survive out of that group. And then the 3 can go into 18 6 times, meaning I'll end up with a 6 on the bottom where the larger number is. Okay. So anyway, I end up with 2p plus 9 there, and I end up with 6 and an 8, which makes 48p with a p plus 4. Okay, so that will be my final result.